All right, today we're going to dive into one of the absolute cornerstones of Python, functions. And we're not just going to define them, we're going to build a really solid mental model that will help you master them for good.
So if you're getting started with coding, does this sound familiar? You spend time writing a few lines of code to do something specific. And then, a little while later, you find yourself writing those exact same lines all over again. Before you know it, your code is just long, messy, and a total headache to manage.
Well, there is a much better way. I want you to start thinking of yourself less like a coder and more like a craftsperson. And what does every great craftsperson need? A well-organized toolbox. In the world of programming, functions are those tools.
Okay, so first up, let's really get to grips with the problem we're trying to solve here. Because writing the same code over and over isn't just a little annoying. It's super inefficient, and it can make finding bugs an absolute nightmare.
And the solution to that problem is the function. This is our first and maybe our most important tool. Instead of building something from scratch every single time, we're going to build a specialized tool that does one job perfectly, and we can use it whenever we want.
So what is a function really? It's just a named, reusable block of code that is designed to perform one specific task. You build this tool once, give it a name, and then whenever you need that job done, you just call its name. It's kind of like grabbing a hammer to drive in a nail. You don't build a new hammer every time, right?
And this whole toolbox approach, it gives you 4 huge wins. Reusability is the obvious one. Build it once, use it 1,000 times. Modularity means you can break a giant complex program down into small, manageable little pieces. This, in turn, makes your code way more readable. And, maybe most importantly, it makes finding and squashing bugs so much easier, because you can just test each little tool on its own.
So how do we get all these fantastic tools for our toolbox? The good news is you don't have to build every single one from scratch. Let's look at how you can start stocking up.
You've basically got 3 main options. First, Python comes with a bunch of handy built-in tools like print or len. They're always right there, ready for you to use. Second, you can import specialty toolkits, which we call modules, for more specific jobs. You know, like importing the math module to get its square root tool. And third, and this is where the real power is, you can design and build your very own custom tools.
Okay, let's focus on building our own tools, because this is where it gets really fun. To do that, every tool needs a blueprint. In Python, that blueprint is just the function syntax.
Every blueprint you create is going to start with this little 3-letter keyword, def. This is you telling Python, hey, pay attention, I'm about to define a new tool. You follow that with whatever name you want to give your tool, a set of parentheses, and a colon. Then, indented right below it is the code that your tool will actually run.
Check this out. It's a perfect, simple example. We've defined a tool called Say Hello. Its one and only job is to print a welcome message. But here's the really important part. Right now, all we've done is create the blueprint. The tool exists in our toolbox, but we haven't actually used it yet. It hasn't done any work.
To actually get the tool to do its job, you have to call it. And you do that simply by writing its name, followed by those parentheses. That's the signal for your program to say, okay, pause what I'm doing, go run the code inside that say hello function, and then come right back here.
Now, most tools aren't all that useful if you can't give them some materials to work with, right? A saw needs wood, a hammer needs a nail. Functions are exactly the same. They often need inputs, which we call arguments, and they often produce an output, which we call a return value.
And this brings us to a really crucial distinction that trips a lot of people up: parameters versus arguments. Think of it this way. A parameter is the placeholder in the blueprint. It's the idea of a variable, like the name in our greet function definition. An argument, on the other hand, is the actual material you give the tool when you use it. It's the real value, like Alice, that you pass in when you actually call the function.
You can even get fancy and design your blueprint to come with default materials. See here? The MSG parameter has a default value of good morning. This means if you call the function without giving it a message, like we did with intro Alice, it just says, no problem, I'll use the default. It just makes your tools that much more flexible.
Okay, now listen up, because this is a critical rule right out of the instruction manual. When you're defining your function's parameters, any parameter that has a default value must come after all the parameters that don't. Python is super strict about this order, so you've got to remember it.
So, after your tool does its work, it often needs to hand you back a finished product. That's exactly what the return statement is for.
Our calculate area function doesn't just print the area to the screen, it does the math and then returns that final value. We can then catch that value and store it in a variable, like we did here with result.
And the return statement is pretty versatile. It can send back a single value just like we saw, but it can also package up and return multiple values all at once. And here's a fun fact. If your function finishes all its steps and never hits a return statement, it automatically, behind the scenes, returns a special value called none. Finally, let's talk about workshop safety. Every good workshop has rules to keep things organized and prevent accidents. In programming, our main safety rule is understanding where our variables are allowed to be used, and this whole concept is called scope.
And this is the most important safety rule. Think of variables created inside a function as being on your own private workbench. That's the local scope. They only exist while you're working with that specific tool, and nobody else can see or touch them. But variables created outside of any function, they're on the global scope. That's like the shared supply shelf for the entire workshop. Anyone from anywhere in the file can see and use them.
So what happens if one of your tools needs to actually change something on that shared supply shelf? Well, by default, it can only look at it. To get permission to actually modify a global variable from inside a function, you have to explicitly declare it using the global keyword. This is you telling Python, hey, I'm not creating a new private variable on my workbench. I fully intend to change the one on the shared shelf.
And there you have it. Functions are the essential tools that will transform your messy, repetitive script into clean, modular, and really powerful programs. They are the hammers, the screwdrivers, and all the custom-built jigs in your programming toolbox. You have the blueprint, so the only question left is, what tool will you build first?